Yeah, all right, guys. In this video, we're going to start talking about some of the topics in circles and some of the terminology we use in circles. As here we can see are some circles, okay? And we know the following circles instead of all points. A fixed distance from a fixed point. Here's the fixed point, okay? That's the center. Here's the fixed distance. That's the radius, okay? That's the radius. And that's the fixed distance from a fixed point in a plane. In a plane. If it's not in a plane, then it is a sphere. So we have to make sure that it says in a plane. Concentric circles are what we see here. It says bullseye effect, okay? It's two or more circles with the same center, okay? So they're concentric, right? We got tangent circles here, which are two circles that are touching at one point, two circles touching at one point. Here we have intersecting circles, which are two circles touching at 2 points. Two circles touching at 2 points are intersecting circles, okay? So more terminology, okay? We know what the radius is, as we said, from the center to any point on the circle. That's the radius. So we have a bunch of radii here, radii plural, AD, AB, AC, okay, even the ones not shown, AF, okay? A segment is what the radius defined as a segment with one point at the center and the other at on the circle, okay? We have a chord. A chord, okay, is any segment that contains 2 points on the circle. So this is a chord, EF is a chord. The longest chord of the circle is right here. That's the diameter, AD, okay? These chords, here's the chords, EF, okay? GH is a segment, is a chord, but as a line, it's a secant. So a secant is a line that contains a chord. So it's a line that goes through, okay, 2 points on the circle. The diameter, of course, is the longest chord of the circle. The midpoint of the diameter is the midpoint of the diameter is the center of the circle. The tangent line is a line touching at one point, touching at one point. Okay, there's a tangent line touching at one point. A very intriguing concept is that a tangent and a radius will always meet at right angles. A tangent and a radius will always meet at right angles. Okay, it's an important concept to bear in mind. Okay, what else do we have about circles? We know and should know simple formulas like circumference. The circumference formula is given by 2 pi times the arc times the radius, 2 pi r. Okay, so here's our circumference, 2 pi r. Our r value, the radius is right here, 2 pi times that is the circumference. The area is pi r squared. The area is pi r squared, okay? Um, Other parts of the circle that we talk about are what we call arcs, okay? So we have arcs, which are essentially a portion of the circumference. When we talk about arcs, we got to talk about the central angle. The central angle right here is the angle at A, the angle whose vertex is the center of the circle, okay? And so essentially then a central angle is a angle formed by two radii of the circle, okay? Uh, the the portion of the circle which the central angle opens out to is called the arc, okay? And the arc, okay, is effectively also the measure of some fractional part of the circumference of the circle. The arc can be measured in degrees, in which case it's the same angle measure as the central angle. So this, as we see here, arc CB is, okay, measure 99.25 now, which is also the measure of that central angle. So we see that this arc and this angle have the same degree measure. They have the same degree measure, okay? Now we have what we call major arcs and minor arcs, Okay, now, okay, major arc is an arc um, which is over 180 degrees. So first off, we have minor arcs which are less than 180 degrees. So these that are showing now is a minor arc. Now this minor arc really only needs to be labeled with two letters. CB is a minor arc. Okay, I call it CDB just to emphasize the fact that, okay, we're going in the direction from C through D to back to B, as opposed to going all the way the other way around from C to B. Okay, that would be a major arc. So a minor arc is an arc which is less than 90 degrees when the minor arc, or when the arc reaches 180 degrees, which is right about now, it is becoming a semicircle. The semicircle really needs to be named with uh, three letters on the 3 points on the circle. Um, so we would name this CDB. We need to name this CDB because that tells us the direction as opposed to the dotted direction over here. Okay, so major arcs need to be named with three letters. Major arcs, now we're looking at major arcs. Major arc CDB is, okay, this arc here, which is in excess of 180 degrees. Okay, so minor arcs less than 90 only need two letters to be named. They're equal to the measure of the central angle. Semicircle, it is the arc which is 180 degrees. It needs to be named with three letters, 3 points on the circle, and major arcs are in excess of 180 degrees, which also need to be named with three letters. We also see that the arc has a length, okay? The arc has a length, and we will talk about that momentarily, okay? So that is our arcs and our major, minor, and semicircle arcs, okay? That's what we're moving into in section 7.6 now.